In electrostatics, we studied about electric field intensity, what is the force for expression due to Coulomb's law, and what are the various charge distributions we studied in previously. Another feature of static electric field is electric potential. Electric potential is the one of the static electric field produces electric potential. అనదర్ ఫ్యూచర్ ఆఫ్ అంటే స్టాటిక్ ఎలక్ట్రిక్ పొటెన్షియల్ అని ఒక టాపిక్ మనం డిస్కస్ చేయబోతున్నాం. ఇంతకుముందు కూలుమ్స్లో ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ, ఎలక్ట్రిక్ ఫ్లక్స్ డెన్సిటీ అండ్ వాట్ ఈస్ ద రిలేషన్ బిట్వీన్ డి అండ్ ఈ we discussed in the last classes. What is the relation between electric flux density, electric field intensity, D equal to epsilon E. The relation between D and E is epsilon E. D equal to epsilon E. We studied about that. Another feature of static electric field is electric potential. We are going to discuss electric potential ante manaku telisindede with reference to positive to negative. What is the potential? Plus to minus. What is the potential? That is the potential is the flow of electrons is nothing but current. The rate of change of flow of electrons is nothing but potential. The potential is required to move the electrons fastly. The potential is required to move the electrons. That means potential also known as electromotive force, EMF. EMF also known as potential. Okay. Now in electric potential, in electrostatic field, ఎలా ఉంటుందనేది చూద్దాం. Suppose when a test charge is placed at any point in electric field. Suppose the electric field is moving like this. Electric field is moving in one direction. Electric field as it is a vector or scalar. Electric field is a vector. Electric field intensity is nothing but electric field E bar. Okay. Now we are going to discuss about electric potential. When test charge is placed, assume that one charge, suppose the electric field is moving in one direction, the electric field it is also known as force of direction. Assume that it is electric field is moving in one direction. If suppose ఒక charge తీసుకొచ్చి ఇక్కడ పెట్టామనుకోండి, ఒక టెస్ట్ charge that may be positive charge or negative charge. Positive charge, assume that if a test charge is free to move, it does move in direction of the field. If you provide a test charge is free to move, suppose ఈ టెస్ట్ ఛార్జ్ని తీసుకెళ్ళి ఇక్కడ పెట్టామనుకోండి ఎలక్ట్రిక్ ఫీల్డ్లో, ఫ్రీగా మూవ్ అయ్యే ఛార్జ్, ఇట్ డస్ నాట్ మూవ్ ఇన్ డైరెక్షన్ ఆఫ్ ద ఫీల్డ్. It does not move in the direction of the field. That is, force is in this direction. If however the charge is to be moved against the field, the work is to be done. If the charge is moved against the field, the work is done. The work needs to move the charge against the field, and the process of moving the charge against the field, the energy is stored in the electrostatic field. The process of moving the charge against the field, the energy is stored in the electrostatic field, and this energy is in the form of potential energy. Potential energy it is. అంటే ఒక ఛార్జ్ని తీసుకెళ్ళి ఎలక్ట్రిక్ ఫీల్డ్ ఒక డైరెక్షన్లో మూవ్ అవుతున్నప్పుడు ఇంకో డైరెక్షన్లో ఆ ఛార్జ్ని మూవ్ చేస్తే అప్పుడు ఎలక్ట్రిక్ వర్క్ డన్, ఇట్ ఈస్ ఓవర్. అండ్ ద ప్రాసెస్ ఆఫ్ మూవింగ్ ద ఛార్జ్ అగైనెస్ట్ ద ఫీల్డ్, ఎనర్జీ స్టోర్డ్ ఇన్ ద ఎలక్ట్రోస్టాటిక్ ఫీల్డ్. అంటే ఒక ఛార్జ్ని ఆపోజిట్ ఆఫ్ ఫీల్డ్, ఎలక్ట్రిక్ ఫీల్డ్ డైరెక్షన్ కాకుండా అనదర్ ఫీల్డ్ డైరెక్షన్లో మూవ్ చేస్తే, అండ్ దిస్ ఎనర్జీ ఇన్ ద ఫార్మ్ ఆఫ్ పొటెన్షియల్ ఎనర్జీ ఉంటుందన్నమాట. The work done in moving a charge in an electric field against the electric field is nothing but potential. ఓకే, అంటే ఇనిషియల్ పొజిషన్లో ఇక్కడ ఛార్జ్ ఉంది, ఫైనల్ పొజిషన్కి పోయేసరికి ఇక్కడ మూవ్ అయింది అనుకోండి ఛార్జ్ క్యూ, పాజిటివ్ ఛార్జ్, అప్పుడు వర్క్ డన్ అయింది, పొటెన్షియల్ అవుతుంది. వర్క్ డన్ is important for electric potential. Work done per unit charge is known as electric potential. Electric potential is defined as, assume that the charge is initially at A position. Assume that the charge initially at A position and move to B position. What is the potential? VAB equal to work done divided by per unit charge. The charge is positive charge. The potential, now the electric potential is defined as, what is electric potential? The potential of a point A with respect to point B. The potential of point A, assume that the initial point is A, with respect to point B is defined as the work done in moving a unit positive charge. The work done in moving a unit positive charge from B to A or A to B, that is from B to A, is VAB. With reference to final position is B, initial position is A. Okay, the work done in moving a unit positive charge Q from B to A is VAB equal to W by Q. Work done per unit charge is known as electric potential. Now work done in moving a charge in electric field. Make heading that work done in moving a charge in an electric field. Now we go for work done moving a charge in an electric field. Make heading work done. We have to go for work done. What is work done? If you know, you can calculate electric potential. Work done divided by charge, that is the electric potential. Work done, make heading that work done in moving work done in moving a charge in an electric field. Work done in moving a charge in an electric field. Make heading that. Okay, now we are considering a charge. Consider an electric field due to a positive charge. Consider an electric field due to positive charge, and E denotes that electric field. Electric field intensity at any point in the field. Consider a positive charge. Assume that the field is created by the positive charge is Q, and this is the field created by positive charge. And E denotes that electric field intensity at any point in the electric field. The force exerted on unit positive charge is placed at this point. Suppose a unit positive charge, ఇంకో ఛార్జ్ తీసుకెళ్ళి ఇక్కడ పెట్టామనుకోండి, ప్లస్ క్యూ అనేది, ఈ ఛార్జ్ మీద ఒక ఫోర్స్ వస్తుంది కదా. ద ఫోర్స్ ఎగ్జర్టెడ్ ఆన్ యూనిట్ పాజిటివ్ ఛార్జ్. The force exerted on unit positive charge is placed at the point is F equal to QE. F equal to Q into electric field intensity. F equal to QE newtons. Okay, newtons, that is unit is. Because what is electric field intensity E? We know the definition of E equal to F by Q. Force per unit charge. F by Q is the E equal to F by Q. What is electric field intensity? మనకు డెఫినేషన్ తెలుసు కదా మనకు. Force per unit positive charge is known as electric field intensity. దాని నుంచి మనకేమవుతుంది? ఫోర్స్ ఈక్వల్ టు F ఈక్వల్ టు QE న్యూటన్స్ వచ్చింది. ఓకే, ఇట్ రిక్వైర్డ్ టు మూవ్ ద చార్జ్. It is required to move the charge Q through a small distance dl. Assume that ఒక స్మాల్ డిస్టెన్స్ మూవ్ చేయాలి ఈ ఛార్జ్ని. ఇట్ ఈస్ రిక్వైర్డ్ టు మూవ్ ద ఛార్జ్ క్యూ. ఈ ఛార్జ్ని స్మాల్ డిస్టెన్స్ ఇఫ్ యూ వాంట్ టు మూవ్ డిఎల్ డిస్టెన్స్, ఏ స్మాల్ డిస్టెన్స్ డిఎల్ ఇఫ్ యూ వాంట్ టు మూవ్, దెన్ యూనిట్ వెక్టర్ డైరెక్షన్ is, the unit vector in direction of dl is assume that A unit vector. Therefore, the force needed to overcome the force F is F equal to minus QE. Minus QE, unit vector is A, assume that. Okay, the force needed to overcome the force needed to overcome the force F is F equal to minus QE. మైనస్ క్యూ ఎందుకు వస్తుందంటే మామూలుగా ఫోర్స్ ఇంత ఉంది, దీన్ని ఓవర్కమ్ చేయాలంటే మనకి ఎంత ఫోర్స్ కావాలి, దానికి ఆపోజిట్లో ఫోర్స్ ఉండాలి, మైనస్ క్యూఈ. ద డిఫరెన్షియల్ వర్క్ డన్ ఈజ్ గివెన్ బై dw ఈక్వల్ టు మైనస్ క్యూఈ ఇంటూ dl. assume that a small distance is moved. Okay, assume that a small distance is moved. The point charge is QE dl. dl is a scalar. Magnitude. dl is a vector which implies distance dl in direction of mu al, unit vector direction lo. Now what is the total work done in moving a charge from initial position to final position? Total work done in moving a charge from initial position to final position within the field is given by work done equal to integral initial position to final position. Total work done equal to initial position to final position integral differential work done. Differential work done is minus QE dl. We can substitute differential work done as minus QE dl. Minus QE dl. Okay, initial position to final position minus QE dl. Now what is the total work done? W equal to minus Q, charge is constant, and integral initial to final E dot dl. Okay, this is the unit for work done is joule is the unit. Okay, you understand what is the total work done is minus Q initial to final E dot dl. అంటే వర్క్ డన్ కూడా తెలియాలంటే ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఇంటూ డాట్ ప్రోడక్ట్ ఆఫ్ distance, how much distance it is moved. Now electric potential is defined as the potential of point A with respect to point B. Suppose the charge is moved from A position to B position. Initial position is A and final position is B. The charge is moved from initial position to final position. Assume that it is a small distance dl. We want total work done. అంటే ఇంటిగ్రేట్ చేస్తే డిఎల్ని టోటల్ డిస్టెన్స్ వస్తుంది కదా. ఓకే, విఏబి ఈక్వల్ టు, నౌ వి గో ఫర్ ఎలక్ట్రిక్ పొటెన్షియల్. ఓకే, ఎలక్ట్రిక్ పొటెన్షియల్ ఈజ్ డిఫైన్డ్ యాజ్ the work done in moving a charge from B to A is given by the work done moving a positive charge Q from B to A, opposite of electric field. VAB is given by B to A అంటే మనం B to A to B అని రాయాలి. The work done in moving a unit positive charge Q from B to A, opposite of electric field కాబట్టి B to A is given by VAB అని రాయాలి. అంటే ఏ టు బి అని కాదు, ఇది బి టు ఏ. ఓకే, విఏబి ఈక్వల్ టు వర్క్ డన్ పర్ యూనిట్ చార్జ్ ఈజ్ నోన్ యాజ్ ఎలక్ట్రిక్ పొటెన్షియల్. ద ఎలక్ట్రిక్ పొటెన్షియల్ ఈజ్ డిఫైన్డ్ యాజ్ ద వర్క్ డన్ ఇన్ మూవింగ్ ఏ యూనిట్ పాజిటివ్ చార్జ్. వర్క్ డన్ డివైడెడ్ బై టైం, charge, it is potential. That equal to W already we obtained, minus q b to a e dot dl divided by q. Okay, e dot dl divided by q. Already we obtained W, that is minus q e dot dl, initial position to final position, and divided by the charge. Q get cancelled. Therefore, electric potential from moving a positive charge B to A is A to B is VAB equal to, అంటే ఛార్జ్ B to A మూవ్ చేస్తే ఆపోజిట్లో పోతేనే ఎలక్ట్రిక్ పొటెన్షియల్ వర్క్ డన్ అయినట్లే. ఒక ఎలక్ట్రిక్ ఫీల్డ్ ఈ డైరెక్షన్లో ఉంది అని చెప్తున్నాం కదా, దానికి ఆపోజిట్లో పోతేనే వర్క్ డన్ అయినట్లు. అదే ఫీల్డ్లో వెళ్తే ఏమవుతుంది? ఓకే, VAB ఈక్వల్ టు మైనస్ ఇంటెగ్రల్ B to A initial position to final position B to A E dot dl joules per coulomb. The electric potential is given by B to A E dot dl minus, that is already minus q get cancelled, minus B to A E dot dl joules per coulomb or volts it is. మామూలుగా మనం వోల్టేజ్ అంటుంటాం కదా, ఆ వోల్టేజ్ ఎలా వచ్చింది అంటే work done in moving a unit positive charge against electric field is known as electric potential. Okay, that is VAB equal to B to A minus integral B to A E dot dl joules per coulomb or volts. The unit of electric potential is volts. That is VAB equal to VAB. How can you obtain? VA minus VB. The potential at A point, B point. It is also known as VAB, written as VA minus VB. VA minus VB we can write. VA minus VB, where VAB is may be considered as potential difference between the points A and B. The VAB is considered as potential difference at points A to B, A and B. Electric potential is vector or scalar? The electric potential is a scalar quantity. Electric potential voltage is always a scalar quantity. VA and VB are absolute potentials. Okay, what is absolute potential? That we'll discuss later. What we have to remember in electric field potential, electric potential, VAB is given by, this formula is very important. We have to remember how VAB can be written as minus B to A E dot dl. This formula we have to remember. How we obtained this formula? That is derived. The work done per unit charge in moving a unit charge from B to A in the field of E. అంటే ఎలక్ట్రిక్ ఫీల్డ్లో మనం B to A ఒక ఛార్జ్ మూవ్ చేస్తే ఆపోజిట్ ఆఫ్ దట్ VAB is positive. If the work done is external source is moving the charge against direction of E, VAB is positive if the work done by the external source is moving the unit charge from B to A against direction of electric field E bar. Okay, what is the potential unit? Electric potential unit is joules per coulomb. Joules per coulomb, or we can write volts. The potential 1 volt ante emi 1 joule work is done in moving a unit positive charge or unit charge from one point to another point in the field of E bar. In the field of E bar, if you move 1 joule work, 1 volt means, what is 1 volt? 1 volt means potential difference is 1 joule of work done in moving a unit charge from one point to another point in the field of E bar. That means 1 volt equal to 1 joules per 1 coulomb. 1 volt equal to what is 1 joule work oka unit charge, that is 1 coulomb. 1 joule per 1 coulomb, that is 1 volt.